Hello there, Calculus 2 students. I received a request for help with this question, which involves an anchor and a rope and a catenary. So let me click on the view an example. So I will do the example, and then you can apply what I'm going to do with the actual problem. So a climber anchors a rope at 2 points of equal height, separated by a distance of 140 feet. The rope follows the catenary f of x equals 320 times the cosh of x over 320 over the interval from -70 to 70. The climber climbs onto the rope and pulls himself to the rope's midpoint. Because the rope is supporting the weight of the climber, it no longer takes the shape of a catenary. Instead, the rope forms two sides of an isosceles triangle, more or less. Compute the sag angle theta, illustrated in the figure, assuming that the rope does not stretch when weighted. The length of the rope is 141 feet. Okay, so part of the issue here is just trying to figure out what's being talked about. So let me show you a Desmos graph. Okay, so we have this rope that's anchored, and then we put a climber on the rope. And when they climb on the rope, they pull the rope down towards them. So it was forming this kind of red catenary, this very slight curve, until we yanked on the rope and then it came down. And it's forming an angle in there. So we want to figure out that angle. So that's the key. So we're going to try to draw a diagram to mimic this. And here's that diagram. So we have our sag angle right here, that's theta. B is the catenary. It's where the curve would be if, or the rope would be, if we allowed it. And then A is the distance that is getting pulled on by the climber. And C is the rope now that the climber is on it. Okay, so we have to keep a couple things in mind. They tell us that, if we go back to the problem, that the rope, okay, that the 2 points are separated by a distance of 140 feet. Now remember, that's the whole distance from all the way over on the left to all the way over on the right, from over here to over here. So if the whole distance is 140, then half the distance would be 70. So that means that this distance right here is 70 feet. But then they tell us that the rope is 141 feet and it's stretched taut. So it's 141 feet and there's no stretch when it's weighted. So if the rope is 141 feet, then that means that the hypotenuse of the triangle can also be figured out, because half of 140 makes 70 and half of 141 makes 70.5. So let me just write this out. B is 140 divided by 2, and C is 141 divided by 2. B is because of the anchor points. Sorry, I spelled anchor wrong. Anchor points, right? C is because of the rope. Now, because this is a triangle as far as we are concerned, right, a right triangle, right? In other words, we're treating that catenary as if it was a straight line. I mean, it was straight-ish, but not exactly straight, but we are treating it as if it's straight. Therefore, we know that the angle B divided by C is the cosine of that angle theta. So, sorry, I said that wrong, but the cosine of angle theta is B divided by C. It's the adjacent side divided by the hypotenuse side. Okay, so we know that the angle theta, cosine of angle theta, is 70 divided by 70.5. Okay, well then to find theta, we have to invert the cosine, right? So theta would be the arc cosine of 70 over 70.5. And I believe they want this in degrees. So we can do this in Desmos, if I can show you. The thing about Desmos is you got to be careful about what mode you are in. So let me add an example, or add a piece here. I'm just going to add a folder and call this calculations. Okay, so we want the arc cosine, or the inverse cosine, it's the same thing, of 70 divided by 70.5. Now, You might think, what is that? That's radians. If you look here, radians is dark. So that's a radian measure. If you want it in degrees, you have to click degrees. So that way the degrees is dark and highlighted. And it's 6.83 degrees, or 0.119 radians. So that's what I would say theta is approximately. So theta is approximately 0.119 radians, which is not really a unit, but which is 6.83 degrees. And I believe the degrees is what they were actually looking for. Now you'll notice that the hyperbolic cosine and all of that never really came into play, right? The catenary is the hyperbolic. It's just that the catenary is so slight. I mean, when you look at that curve, it's so slight that we essentially are treating it as if it was a straight line. It isn't. It's going from 320 all the way up to 327 over the course of 70 feet. But it's close enough-ish to straight for us to treat it as such for the sake of an approximation, which is all this particular problem is asking for. Let's go double back to the question and just make sure I answered everything. So the length of the rope is that. Compute the sag angle. Nope, I think we did it. So we're set. And I guess I could click on all of this. And yep, it's showing me exact same answers that I just got. So I know I did it right. All right, I hope that helps.